Hello there. Thank you once again for joining us here on our learning series. My name is still Hamza Ruwama. Thank you for liking our channel and thank you for being part of this math class. We promise to be having live classes soon. We shall be communicating when to have them. And always remember to put your comments in the comment section. Put some integrals or some numbers you have there that you want us to look at. And then we can also have some personal online classes, online one-on-one coaching and assistance for learners of the curriculum of East Africa, for learners of the curriculum of the British Council and Cambridge Council. So all those people who are within those categories, we can always have some one-on-one assistance, both in mathematics and in physics. So today we are back again for integration. And this time around, we want to look at what we call Pythagoras theorem, even powers, or and odd powers, categories of integrals which are in that form. An integral of the form whereby, for example, it has a very big power. Well, the power is not so big that it cannot be split. It is big enough to be split. For example, you can be given example 1. You can be asked to integrate sine to the power maybe 5 of x with respect to the x. 5 is an odd power. You know, odd numbers are numbers which when divided by 2, they leave a what? A remainder. So I can split this integral into the following. 1, sine to the power 4 of x, sine of x dx. And it is always very good to follow these series of the videos as they move. For example, we had type 1, it's better to go to type 2 after seeing type 1 because the integrals connect at one point. If yes, I go back to trigonometry, because these are trig functions, always have trig definitions and trig identities close by. From trigonometry, we know very well that cosine of squared x plus sine squared x must give us a 1. From here, I can make sine squared the subject. Why? Because sine to the 4th is the same as sine to the square of x, but the whole of that raised to the square. With that regard, therefore, integral of sine to the 5th of x dx, I can rewrite this as sine to the square of x, but this is squared times sine of x dx. From this definition, I can make sine squared the subject, which is 1 minus cos squared. So this will give me the integral of 1 minus cos to the square of x, but the whole of this is squared sine of x dx. It is from here that I can expand and I'll realize the following. Integral of 1 minus 2 cos squared of x plus cos to the 4th of x, close brackets. The whole of this has a bracket of sine of x dx outside. Then you can make the sine of x penetrate into the bracket, and when you do so, this is expected. We shall have integral of sine of x dx minus integral of twice cos squared of x sine of x dx plus the integral of cos to the 4th of x sine of x dx. Now when you reach this step, you realize that your definition, you can no longer go into the way we have been doing type 1. By now, you should have mastered type 1, and some of these integrals can become obvious to us. How? For example, I asked myself, because the other type 1 was inspections. So even here, you can still ask yourself, what do I differentiate to get sine? I differentiate a cos. When I differentiate a cos to get sine, if I want to come back from sine to go back to where I came from, I integrate the sine and I'll realize the result as a negative cos of x. Then the second term. The second term has a cos squared as the highest degree with sine of x, meaning sine of x is coming from the derivative of cos. But to realize this, we must have differentiated cos cubed, which cos cubed is missing in the function, and even the 3 is missing. So when you differentiate the cos cubed, you get a third. So because of integration, that's why we divide off and get a third, and we shall have this result as 2 out of 3 cos cubed of x. But because we differentiated the cos, it gives us a negative. Then plus the integral of cos to the power 4. The same idea we have borrowed here. is the same idea we shall borrow on this term. Where we have cos power 4 as the highest degree, it must be the one we differentiated to have got this sign of x at one point. So inspect cos to the power 5 using type 1. So cos to the power 5, because the 5 is missing and we are integrating, I can divide off the 5. Then when I divide off the 5, I must have differentiated cos to the power 5 of x, which derivative gives me a negative plus a constant of integration. It is from here that we shall realize a negative cos of x plus 2 over 3 cos cubed of x, a plus, a minus 1 over 5 cos to the 5th of x plus a constant. And these are the solutions, or this is the solution to our integral of cos to the power, is sine of to the power 5 of x integrated with respect to x. This is when the power is odd. Whenever the power is odd, you split the power into odd and even. That's why you ended up seeing me saying this is 4, power 4, and this is power 1. So whenever you have odd powers, we split the powers to odd and even. Whereas for even powers, we should always borrow what we call double angle formula. For even powers, you should always recall cosine of 2x is 1 minus twice sine squared of x. The same also cosine of 2x is the same as twice cos squared of x minus 1. So those are the ideas we should borrow whenever we are to deal with even powers. Then from that, you can mix the two equations or functions, and then we can see how best we can go over the number. So, for example, question 2, integrate cos squared of x dx. Come back to this definition. What is cos squared x? Cos squared x is actually a half plus a half of cos of 2x dx. Whenever we are to integrate a trig function, the integral of a half is direct, it's a half x. Whenever you are to integrate a trig function, you first differentiate the angle. The constant you get, for example, when I differentiate 2x, I get 2. Divide off that constant, so the coefficient here will become a quarter. We ask ourselves, what did we differentiate to get cos? We differentiated sine. The derivative of sine is a positive, so the answer will become a half, a plus, a quarter sine of 2x plus a constant. With this, you would have handled an even power, which is in terms of sine and a direct sine. I mean in terms of cos squared x, and which is a direct cos, which takes us to sine of 2x. This definitely would mean, according to this one, actually I've missed the integral of a half. This a half, when you integrate it, you must have got x, so I missed the x. So if a half, the integral of x is a half is x, the integral of cos of 2x over a half is a quarter sine of 2x. So this would give you the solution to the integral of cos squared x. So let's also check out the integral of sine squared of x. The integral of sine squared. Actually, I can check sine squared of 2x with respect to x. In this case, one, I should ask myself, where does sine 2x come from? This must be coming from cos of 4x, which is equal to 1 minus twice sine to the square of 2x, because double angle or half angle formula talks about halving the original angle. That's why the sine has a half of the original angle. It is from this note that you can make sine to the square of 2x the subject, which is 1 minus a half cos of 4x. When you substitute, you realize that, this is example 3, you realize that integral of a half, actually the integral of sine squared of 2x has now become integral with respect to x, has now become a half minus a half cos of 4x, the whole of this integrated with respect to x. So when I integrate this, I'll realize the following. The integral of a half is a half x. The integral of cos, you ask yourself, what did we differentiate to get cos? We differentiated sine. If we differentiated sine, when you differentiate sine, you get a positive, so the sine remains as it is. Then differentiate the angle. When you differentiate the angle, you get a 4. Because of integration, divide the 4, and you'll get a negative, an eighth sine of 2x, because the integral of cos is sine plus a constant. So with this, the solution becomes a half x minus 1 out of 8 sine of 2x plus a constant of integration. Earlier on, we had said the constant of integration actually stands in for indefinite integrals, meaning we are not sure where it stops, but if they tell us where exactly it stops, then that one we shall be dealing with what we call the definite integral. Okay, we have example 4. And in example 4, we have cosine to the 50th of x. Cosine to the 50th of x can be split. Remember I said for odd powers, you split into odd and even. So I can split it into co-integral of cos to the 4th of x, cos of x with respect to x. But also still, we had seen earlier, cos to the square of x, when you raise it to the square, this is what you realize as cos to the power 4 of x, which is going to be 1 minus sine to the square of x, the whole of it raised to the square. For that, I can now go further and say integral of cos to the 50th of x with respect to x is going to be cos power 4 is the same as this, and I can expand it. When I expand cos to the power 4, I'll have integral into 1 minus 2 sine squared of x plus sine to the 4th of x cos of x dx. When I integrate this, I can have first expand, and I will get integral of cos of x dx minus 2 integral of sine squared of x cos of x dx plus integral of sine to the 4th of x cos of x dx. So we use the earlier technique I mentioned in the beginning. What do we differentiate to give us cos? We differentiate sine. So from cos to go back to sine, it's a positive. So this is sine of x. Here this is raised. The one with the highest degree, increase its power and inspect. Sine cubed, when you differentiate, you get 3 sine squared cos x. So when I integrate it back, I must have got what? A negative 2 over 3 sine to the cube of x. If you're not able to see this, you go back to type 1 and watch the video again and see how we realize this by inspecting or by inspection. Type 3 will be change of variable, which is another technique which can handle such problems. But for now, we are dealing with odd and even powers directly. A plus, sine power 4 must be coming from the derivative of sine power 5, which is 1 over 5 sine to the 50th of x with respect to x. So in conclusion, the integral of cos to the 50th with respect to dx is sine of x minus twice over 3 sine to the cube of x a plus 1 over 5 sine to the 50th of x a plus a constant. So with that, you'd have solved the problem of having an integral of cos to the 50th of x with respect to x. Like I've already said, I can't just leave you there without a number. Allow me to give you some 2 or 3 numbers that you can try out, and then you can put your solutions in the comment section. So you can try out these examples. Integral of sine cubed of 2x with respect to x. Then try out also integral of cos to the power 4 of x out of 2 with respect to x. Those will be very good examples for you to try out, and I trust that if learners have really been part of this series and they have been really active and present, they will be able to handle these problems. In case of any challenges, reach me out in the inbox. I can always come in and help. Otherwise, my name is still Hamza Rwama, and I'm happy to be with you and to be part of this series. And I'm also glad that you liked the video and you've been watching and you've managed to subscribe, please keep watching and share the video to your other students, other colleagues, other teachers, so that they can also enjoy the video.